My name is Tiffany Ye, and today I will be giving a brief instruction on how to solve stoichiometry problems using dimensional analysis. These are the objectives I hope you will grasp at the end of the video. The first is to describe the purpose of unit analysis. The second is to recognize when to use dimensional analysis, and the third is to know the importance of dimensional analysis in chemistry. We'll start with the definitions of dimensional analysis and stoichiometry. To begin, dimensional analysis is the analysis of relationships between metric quantities such as mass, length, temperature, and time, without changing the initial given value. In other words, a value may have a certain unit, but the problem calls for a different unit. Next is stoichiometry. Stoichiometry is a section of chemistry that involves using relationships between reactants and/or products in a chemical reaction to determine the desired quantitative data. This is a table of conversions one may find helpful in chemistry's dimensional analysis. It is standard for scientists to use the metric system instead of the imperial system. This is because the metric system is used in almost all countries around the world. Here are the steps to solve a stoichiometry problem. Number 1. Gather the chemical equation and givens. It is best to read through the question and determine a list of givens, if there is more than one, and figure out what the question is asking for. An example is provided in Figure 1. Number 2. Balance the chemical equation if not already done so. We need to work with a balanced equation or else our final solution would be incorrect. Number 3. Set up the dimensional analysis equation with the givens. Usually there is one main variable to focus on, and the others are used as aid to help figure out the solution. Number 4. Convert the givens units using the conversion chart and periodic table. A periodic table will be provided in the next slide. Let's try an example to put the steps into use. How much magnesium oxide will be produced if 8 grams of magnesium ribbon is burned? The chemical equation is 2 magnesium plus oxygen reacts to become 2 magnesium oxide. First, we jot down the given and figure out what we have to solve for. In this case, it is grams of magnesium oxide. Next, we set up our dimensional analysis equation to convert the units. 8 grams of magnesium is in the numerator, while 1 is in the denominator, because we have no underlying units or values to 8 grams. To convert 8 grams of magnesium to grams of magnesium oxide, we must use each of the substance's atomic mass. This is usually measured as AMU, which stands for atomic mass unit, or grams per mole. For our problem, we will be using grams per mole. According to the periodic table, magnesium weighs 24.3 grams per mole. 24.3 will be our denominator, while mole is our numerator. Next, we will convert our magnesium mole to magnesium oxide moles. This is where the chemical equation comes in handy. It says that 2 moles of magnesium will create 2 moles of magnesium oxide with the help of 1 mole of oxygen. So for our equation, 2 mole of magnesium is our denominator, while 2 moles of magnesium oxide is our numerator. We're at the final stretch to find out how much of magnesium oxide will be produced. By looking at the periodic table again, magnesium has an AMU of 24.3, while oxygen has an AMU of 16. Adding the 2 numbers together, we will get the AMU of 40.3 for magnesium oxide, or 40.3 grams per mole. Now we can cross out the same units at the numerator and denominator. Grams of magnesium can be crossed out, moles of magnesium can be crossed out, and moles of magnesium oxide can be crossed out as well to leave us with our solutions unit, grams of magnesium oxide. We then multiply all numbers in the numerator and divide that by the numbers in the denominator to get 13.27 grams of magnesium oxide. Let's try one more example. This time, Try solving this yourself by pausing the video. I will walk you through the work to double check after. Okay, now let's create our given and solution list. It seems the equation is not balanced either, so we'll adjust that. It turns out that 2H2O2 dissociates to become 2H2O liquid and O2 gas. And here is our dimensional analysis equation. 9.37 moles of H2O2 can be multiplied by 1 mole of O2 over 2 moles of H2O2 to get the answer of 4.69 moles of O2. This leaves us to cross out the H2O2 mole unit. I hope the examples gave a clear picture of how to use the steps. Remember, always write out the given variables and balance the chemical equation. Use the conversion factors in the periodic table. And lastly, remember that only the units are changing to solve for our answer. The conversion factor values will make up for the change. Thanks for watching.